All right, guys, we are back and we are jumping into set builder notation. For the next part in our video series here, we're in chapter 1.1. So section 1 of chapter 1 here in our Algebra 2 full course video series. All right, so our focus in this video is we're looking at set builder notation, translating between notations. And we'll just read really fast. Another way to represent sets is set builder notation, which uses the properties of the elements in the set to define the set. Inequalities in the element symbol are often used in set builder notation. The set of striped billiard balls numbers, or 9, 10, 11, 12, 13, 14, 15, is represented below in set builder notation. So how do we read this? Let's go through each part. The set of all numbers x such that x has the given properties. And here they are. All right, so the set of all x such that, and then the condition. So set builder notation describes a set by stating a rule that every member must satisfy. And we saw that the vertical bar here is read as such that. So let's say I have, let me write down an example here. Let's say I have, let me write that better. Let's say that I have x here, and then the bar, and then x equal sign with a line through it, 0, and my closed brace there. So how would I say this out loud? Aloud. I will say the set of all x such that x is not equal to 0. All right. How would we read our example here? Let's take a look at our text. The set of all numbers x such that x is greater than 8 and less than or equal to 15, and x is a natural number. Now let's go over to our methods of set notation. And we'll just look at our table here really fast, our reference table. All real numbers except 1. Our roster notation cannot be written in roster notation. Here's our interval notation and our set builder notation. Positive odd numbers, here's our roster notation, cannot be noted using interval notation. Here's our set builder notation. And then numbers within 3 units of 2 cannot be written in roster notation. Here's our interval notation. Here's our set builder notation. So you guys can take note of that before we continue on to our example. Just keep in mind that our symbol E there means is an element of. Now let's bounce on over to example number 3. Translating between methods of set notation. Rewrite each set in the indicated notation. So we're going to read the set builder notation aloud first. The set of all x, check, such that x equals 2n, and n is a natural number. So let's think about what values x takes. If n equals 1, x equals 2, and if n equals 2, x equals 4. If n equals 3, x equals 6. So the question we can ask is, what pattern does x equals 2n produce for natural number values of n? Even numbers, 2, 4, 6, 8. So we'll write x equals 2n where n, here's our element symbol, Let's open up that brace. 1, 2, 3, our ellipsis. We'll close the brace there. Gives X element. And now let's put in our even numbers. Here's our open brace, 2, 4, 6, 8, and go ahead and give an ellipsis again to show that that continues on. All right, my tablet is so sensitive. Every time I touch something, it'll bring something else up. All right, so our answer, the set of, and we can write this out, the set of positive even numbers or even natural numbers. All right, let's look at 3B. Numbers and symbols on a telephone keypad, roster notation. All right, and here we see 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, star and, or asterisk there, pound, star, pound. Okay. So here we're going to list all the elements of this set between the braces, and I want you to note that the order does not matter. There's our little note there, in set notation, right? All right, so what symbols are on a standard telephone keypad? Here they are, 0 through 9, plus our star and our pound. So let's go ahead and write that out. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, star and pound. And notice we have an open and a closed brace. This is a finite or infinite set. Finite. Roster notation is perfect for finite sets with clearly identifiable elements such as numbers and symbols on a telephone keypad. Okay, what about 3C? Now we're looking at set builder notation. So we're going to read the number line. We have an open circle at -3. So it's not included. 5 is included with the closed circle. So the set contains all real numbers in this range. Now what inequality will match this number line? Here we are. Let's go ahead and write out just the inequality sign would be this part, right? X is greater than -3, but less than or equal to 5. And now we're ready to put this into our set builder notation. There's our brace, open brace. The set of all numbers x such that x is greater than -3 and less than or equal to 5. All right, let's take a look at our 3A, 3B, 3C part. We're going to rewrite each set in the indicated notation. So we'll describe what all 4 elements have in common. What kind of numbers are 2, 4, 6, and 8, for example? Positive even numbers or even natural numbers from 2 to 8. So we're going to have the set of positive even numbers from 2 to 8 or even natural numbers between 2 and 8 inclusive. Let's write that out. The set of positive even numbers from 2 to 8. Okay. Now we're at 3B. So this asks for natural numbers or counting numbers strictly between 2 and 8 we see here. Since x must be a natural number, let's list only the whole number values in 2, 8. So which natural numbers are greater than 2 and less than 8, in other words? That would be 3, 4, 5, 6, 7, right? So let's go ahead and open up our brace and write 3, 4, 5, 6, 7, and then close the brace there. And then we're at 3, see? We're going to translate this to set builder notation. All right, so 99 positive infinity means x is greater than or equal to 99 for our open bracket there with no upper bound. So what inequality corresponds to 99 infinity here? Let's write that out. X is greater than or equal to 99. And that is our answer. Let's go to our think and discuss. And this will be our last section of this video, and we'll be jumping into the exercises in our next video. Let's go to our think and discuss. We're comparing interval notation and roster notation here in number 1. Is it possible to have a set that can be represented by both? So think about what each notation can describe. Roster notation lists individual elements. Interval notation describes a continuous range. Can a set be described both ways? Can you think of any set that both has a finite list and represents a continuous range? And the answer, of course, is no. Interval notation describes all real numbers in a range, infinitely many, while roster notation lists specific elements. A finite discrete set like, let's say, 1, 2, 3, cannot be written as an interval because, for example, 1, 3 would include what? 1.5, 2.7, etc. So what's our answer? For most infinite sets of real numbers, interval notation works. Roster notation is for countable discrete sets. They can both be written only in special cases where a finite set happens to span a range, which is essentially never for real numbers. All right, so what's our core insight here? That the real number line is dense. Between any two reals, there is always another real. That was our note way over here. The density property. Whoops. That we were looking at in our previous video. All right, what about number 2? Explain whether it is possible to name a number that belongs to both the set of integers and the set of irrational numbers. Now let's think about what integers are and what irrational numbers are, what we've been discussing here in 1.1. Every integer can be written as what kind of fraction, for example? Every integer can be written as n over 1, which is a ratio of 2 integers. So every integer is rational. Since integers are rational, and rational and irrational numbers do not overlap, no integer can be irrational. So our answer is impossible. Impossible. Integers are rational by definition. N is equal to n over 1 always. Any number divided by itself. That's a ratio of 2 integers. So every integer must be rational. All right, so what's our answer? Integers are rational by definition, and rational and irrational are mutually exclusive subsets of real numbers, right? All right, what about number 3? We're going to complete the graphic organizer here. So we want to fill in each cell of our table. If a notation cannot represent that set, we would write cannot be written and explain why. All right, so for row 1, we have 1, 2, 3, 4, 5. Okay, that's a finite set. So our roster, let's write that out. It's not as easy to write that one, the brace there, but it looks kind of like a bird, doesn't it? Like a bird flying. That's the way I think about it. 1, 2, 3, 4, 5, and then close it out. All right, what about interval notation? Cannot be written. Interval would include non-integer reals. What about set builder? Okay, this one we can. Let's go over here and write our set builder. Open up that brace. Write our x, our slash 1, with x there being greater than or equal to 1, and then less than or equal to 5. X element symbol, and our n. Make sure we close out that brace. All right, let's go to row 2. Put an X here. Cannot be written because the interval would include non-integer reals is what we would write into that space if we're in class, right? All right, what about our next row here? We have n greater than or equal to -2, less than or equal to 2. This is a continuous range, so it cannot be written in a roster. Why? Because it has infinitely many real values is what we would write into there. I won't spend time on that, but that's what we would write into there for the explanation of why it's not going to work. Let's move on to interval. We're going to have our bracket, open bracket, -2 and +2, close bracket. Remember, it does include -2 and 2, so let's use those open and close brackets. And then for our set builder, we'll have our open brace. Again, I'm struggling with that. Open brace, and we'll have x. Let's draw our slash -2. Put x there in the middle. It was greater than or equal to, right? And that it's less than or equal to +2. And then we'll close our brace. All right. That's continuous, so that's done. Now let's go to row 3, whole numbers less than 3. So our roster is going to include 0, 1, and 2, but let's stop there. It says less than 3, right? Interval cannot be written precisely as a discrete set, and our set builder notation. Let's go there last. Here's our open brace, x, our bar, x is less than 3, x, our element symbol, and a big W. All right, now if you need a refresher on our letters here, what they stand for, N is for natural numbers, W was for whole numbers, Z for integers, Q for rational numbers. These are all real numbers. And that will do it. That is the end of 1.1's lessons, section 1 here. Now we'll be moving on to our exercise set, and we'll divide that up into some videos because there are quite a few problems to go through. I probably won't go through every one of them, but I will try to get to as many as possible, the ones that are most important for this course and for practicing. All right, we'll see you guys soon. Take care. Bye.